The job of building systems with software and writing code to support that effort is a complicated one, and it's so widely practiced in such a diverse range of circumstances that it may seem hard to generalize. But there are commonalities, and categorizing things is kind of in our nature as human beings. So one of the categorizations that I sometimes make is of types of programmer. There are lots of ways in which we can think about categorizing programmers, by language, by architectural layer perhaps, or maybe even some other technical specialization. But the categorization that I have in mind seems more foundational to me. It's about how programmers think about and organize their work. Whatever language you use, largely whatever the level of your experience, and mostly whatever the nature of the software that you create, seems to me that there are three types of programmer. So what are the differences, and which one are you? That's our topic for today. Hi, I'm Dave Farley of the Modern Software Engineering channel. Welcome. If you haven't been here before, please do hit subscribe. And if you enjoy the content today, hit like again so that more people get to see it. Thank you. My three different types of programmer are the coder, the software developer, and the software engineer. I don't think that these are necessarily about levels of experience, although that may play a part for some people. I don't think that these categories are only arbitrary labels either, that all fundamentally mean the same thing. To my mind, what we're talking about are distinct groups that behave differently and get quite different results. And even though one programmer may play each of these roles at different times, these are not necessarily, but maybe partly, about the ability and skill of the individual programmer. They're often much more likely to be a function of the environment that we find ourselves working in. I suppose that in some ways this is related to Kent Beck's idea of the forest and the desert. Ideas that are sensible in the harsh conditions of the desert seem like poor choices in the lush richness and easy living of the forest. And the ideas of the forest seem like unobtainable idealistic nirvana from the perspective of the people in the desert. The thing is that you can move to the forest, making life easier by changing your ideas or changing the group that you work with. Though naturally, neither one of those is necessarily an easy thing to do. But recognizing that you're in the desert and that there is a forest is hopefully a helpful place to start, to help you to decide whether you think that working to change is worth the effort or not. So back to my three groups. I think that you can fairly clearly delineate these groups in some meaningful, practical ways. Coders translate detailed descriptions of what to build into code that implements it. They see their primary skill, I think, as the ability to speak a programming language. But there are problems with this worldview, which we'll come to. Coders behave as though understanding the problem that they're working on is not really their problem. It's secondary to the act of writing code. They're resistant to testing their own code because that's not my job either. Often in the more dysfunctional organizations, coders are the victims of a kind of learned helplessness. I can't spend my time on design because it's not in the plan. I can't change that code, my boss won't let me. We have to use those tools because the architect said that we must. In my experience, this kind of thinking is depressingly common, from the perspective of a forest dweller at least. These ideas may make sense if you live in the desert, though. In one organization that I worked with, a coder told me a story. He'd been working in an area of the code and noticed a problem with it, which had led to a bug. So he fixed the bug. Later, a project manager came along and told him to remove the bug fix because the bug fix hadn't been in the plan. In another organization, I was pairing on some refactoring with a reasonably senior developer from the team. And I said, we could create a new class for that. And his whole body language changed. He kind of slumped in his seat. What's wrong? I asked. We have to change 5 configuration files and raise a ticket to add a new class, he replied. Clearly, in both of these examples, these are behaviors that were imposed on programmers by the organizational culture, forcing them into the role of coders rather than anything else. In the first case, even as the developer was trying to do the right thing and aspiring to work more like a software developer, taking more ownership rather than as only a coder. This is depressingly common, but the really insidious part is that people working in environments like this start to assume that this is normal, and so they reinforce it more for themselves. So if you've ever said, "It's not my fault, someone else didn't get the requirements right," you're probably working and thinking more like a coder. Coders often use this external control of their work as a kind of excuse to avoid doing the things that they don't really want to do. "I can't write tests because my boss won't let me." Lots of organizations structure things to work like this, but I've never seen it work well in my 40-odd years of professional software development. Sure, coders can produce systems, but they're never systems that people love or that are clever or that are nice to work on. My experience has been that developers need to be much more deeply involved in the process of producing the software and thinking about the ideas than only working as translators into code. Let me pause there and say thank you to our sponsors. We're fortunate to be sponsored by Equal Experts, Transfic, and Tuple. Tuple builds software to make pair programming easier for people who work remotely. The tools are excellent and allow you to do screen sharing, code sharing, keyboard sharing, and so on. All of these companies, though, offer products and services that are well aligned with the topics we discuss on this channel every week. So if you're looking for excellence in continuous delivery and software engineering in general, please do click on the links in the descriptions below and check out the services and products that our sponsors provide. I think that these programmer groups represent a progression in the value of the individuals to their employers. As you progress through these levels, the contribution that you can make to any software project improves. So while coders can build systems that work at some level, they're not likely to build as good a system as someone at the next level of software developer. A software developer takes more personal responsibility for their work. If you'd like to learn more about what I think this entails, check out my free how-to guide on the topic of great developer habits. There's a link to that in the description below. Software developers see their job as solving problems for other people using software as the tool, rather than translating some predetermined solution into code. You can think of this as their job being primarily the design of the system and all that that entails. I spent most of my career thinking of myself primarily as a software developer, and mostly I still do. For me at least, the difference between coder and software developer is pretty stark. There are no circumstances when I think it's better, as in more effective, to organize software development around coders in preference to software developers. You will always get a better result if you treat software development as more than only a simple translation of a specific solution into code. But this mistake is still incredibly common. The problem is that this is what maybe even the majority of big organizations think is necessary to scale software development up. However, this is really a 21st century version of Taylorism, the philosophy of so-called scientific management that was largely discredited by the 1930s. Taylorism was a fairly basic approach to trying to decompose work and was part of the thinking that led to the early production lines. It worked to some degree for work that was not terribly creative, so not much like software development. So if I make a wheel and you fit the wheel, we can each focus on and become very good at our separate but related specialities. But there's clearly some form of technical contract at play here. The wheel that I produce needs to work with whatever it is that you need to fit it to. So when that contract may change and we need something more creative than Taylorism, it falls apart. I'm not free to change the design of my wheel because you, me, and whoever is producing the axle that you're fitting the wheel to are coupled via the designs of the wheel and the axle. Actually, this doesn't even work well for reasonably stable things like the designs of wheels and axles. Lean manufacturing proved that there are much more efficient ways to organize work than Taylorism. We want humans to have the freedom to change things in unpredictable ways when they hit an unforeseen problem and work around that problem or solve that problem as they hit it. This is a lot more effective. In reality, that is the step from coder to software developer. The software developer feels the responsibility and has the freedom to correct things as they see fit. The State of DevOps reports, in fact, say that this freedom and sense of ownership is one of the main leading predictors of high-performing teams. I think that this distinction between coder and software developer is perhaps becoming more evident as AI programming gains ground. AIs are very good at translating detailed instructions into code, but understanding the problem at hand well enough to be able to come up with creative solutions and even come up with those detailed instructions is still a difficult job that requires more insight and understanding, more expertise perhaps. Much more difficult than only writing the code. Programming languages aren't the difficult part. If they are, then you're a beginner at programming. Understanding the problem and the design of the solution are the difficult parts, and that's where we should be focusing on becoming excellent. With or without the help of AI assistance, I don't think that this distinction is new. It's just perhaps a little bit more evident now that we have, or are close to having, an automated alternative to coders that just do a translation from a defined solution into working code. So if you recognize yourself as a coder, my advice is to start getting more involved in better understanding the problems that you work on. Develop the skills to adopt a more organized approach to solving problems in general, and think carefully, more critically, about the design choices that you and your team make, and grow your skills in this area too. Obviously, I'm going to recommend the stuff that we talk about on this channel all of the time. Learn test-driven development, learn behavior-driven development, and practice continuous integration and continuous delivery to help you to achieve these things. This is the reason why these things are important. But also, learn how to see your work more from the perspective of a user of your code rather than your own slightly narrower perspective as its producer. And think more about how to write code and develop systems that are easy to change by you or somebody else in the future, and ideally easy to use by your users too. These things are a lot more valuable and more fundamental than understanding the syntax or coding conventions in your preferred programming language. The last distinction, that between software developer and software engineer, is a bit more specific and probably a bit more biased by my own personal biases. But I'd say that there are two defining characteristics for software engineers. They apply a scientifically rational approach to problem solving, the principles of which I describe in my book, Modern Software Engineering. And as a result of this, they are able to determine the releasability of their system after every small change. This second one may sound a bit specific, and it is, but the data from the State of DevOps reports by Dora, which is the most scientifically credible study of software development that I'm aware of so far, says that statistically, continuous delivery is by far the most effective way of organizing our work. It simply produces better software faster. We have more fun while we're doing it, and the companies that work this way make more money. So if engineering really is about doing the stuff that works, then continuous delivery is, as far as we can tell, the stuff that works best. So technical, cultural, and organizational disciplines that make continuous delivery possible do represent a genuine engineering discipline for software development. CD is working so that your software is always in a releasable state. So defining engineering as knowing that your software is releasable seems like a reasonable call to me. The first defining characteristic of the software engineer is important too, though, that rational scientific style thinking. Modern engineering is really the practical arm of science because that's what works best. And engineering is ultimately that most pragmatic of disciplines. If it doesn't work, it's not engineering. Otherwise, your bridge falls down, or your spaceships crash, or your software fails in some equally spectacular way. So having a model for problem solving, being organized about how we go about it, is centrally important for what we do, if we want to do it well anyway. My 5 practices for optimizing for learning are my recommendation for what that model should be. How do you solve a problem when you have no idea what a good solution should be? Actually, how do you solve any complex problem? Because that's kind of the definition of a complex problem. You don't have an idea what the solution should be. You do it by adopting a general problem-solving approach and getting good at it. My 3 categories here aren't based on any science or research, though. These are my subjective opinions, but I do find them useful in categorizing where teams are on their journey towards excellence, and sometimes in figuring out what things they maybe need to think about doing next in their journey forwards. As someone who talks a lot about engineering in software in a software context, I often get challenged by people saying, what we do isn't engineering. And on the whole, if I take them literally, I have to agree. Most software development isn't practiced as engineering. Most, as far as I can see, sadly, is organized into teams of coders. There are many more coders and coder teams than there are software developers. And there are many more software developers and software developer teams than there are software engineers and software engineering teams. Even when we call people software engineers, they mostly don't fit my definition of what a software engineer should be. But I also think that there is no real argument that building teams of coders is the best way to organize things. There's no economic argument or product argument. Coders don't build better systems more quickly or more cheaply than software developers or engineers. I think that decomposing software development into project-managed coding tasks is an exercise in futility, producing worse software more slowly. So is never a better choice, whatever the circumstances. Thank you very much for watching. If you enjoyed the content here today, do hit like. And if you really enjoyed it, why not consider supporting us by joining our Patreon community? I'd also like to say thank you to our Patreon community for their ongoing support. Thank you very much, and bye-bye.